top over here. Not there, here. Go ahead. You have a yeah. So, Mr. Holmesy, I was gonna say, you're not on my roster, so you might want to. I was gonna try to do it generic without calling you out, but make sure that you got to call the registrar and straighten it out. Can you guys hear me? Okay. Let me check my.
Yes, I can. But why was what happened?
It never went through. Just remind me at the end of class, and we'll follow up with that. Like, cause I'm pretty sure I sent what I needed to send. If not, just remind me towards the end of class. We'll take some time towards the end, and we'll see what's going on there. Cause I think I sent to my supervisor. I was like, hey, if they're trying to get into class, or if they say they want to be in the class, just let them in. So we'll just have to follow up with it. There might be an email I need to respond to or something like that. But just remind me towards the end of class.
Yes, sir. Yes, sir.
Yep. Okay. All right. So I was trying out some different things today, just with the visuals and things. We're gonna see how it goes. Let me see if there are any announcements. So, only real announcements today. Again, once you get into, generally, as long as you're on my roster and you get into the Zoom call, you get your attendance credit. Let's see. So on Wednesday, exam 1 is scheduled to open, and it'll be due this Sunday, right? And it should just be over sections 1.1 to 1.4. So we're going to start section 1.4 today. At least as far as like the content is concerned. And we'll be working on it all week. And then so our format has been, we'll take the first part of the week to kind of make our way through the homework as best we can. And then whatever time we have remaining, we use it to get some more practicing on factoring. So, on a weekly basis, I do kind of add a few additional assignments. Those are going to be part of your grade. I don't pull questions directly from those additional assignments for the exams, but they're kind of inherent in like some of the things that we do. You can't do it without factoring. So it's really just practice on background information. Long story short, just be sure to be submitting all of your assignments that you see on Pearson. Okay, let me reboot this because it is kind of slower down. So again, if you have questions, feel free to either unmute yourself or type in the chat. I monitor the chat, and feel free to unmute yourself just to get my attention to ask your question. Otherwise, I'm just going to kind of do what I normally do, where I kind of start making my way through the homework. Let's see. So we can go like this, right? And then, do I need to show that there? Yeah, I do. Yeah, see, I don't know how to get that going. So I'll do this. Okay. I just do it the way I was doing it before. And that should be working now. Oh, okay. Let's stop sharing, and then let's go to share. Now, let me see. That would be the simple one, but I liked that technique. So it was this one. It's mainly those two, right? That one and this one. I think that's all that I need to share. Okay, we're going to share those two. So on Zoom, one of the things that I'm playing around with, I just figured out how to share multiple screens, so that way as I switch between screens, like I don't have to share my whole desktop, which is what I didn't really want to do initially, but that was just a solution to kind of get what I wanted at the time. And so it just this option popped up today. I was like, oh, that's exactly what I was looking for, how to share multiple screens on Zoom. So that's one of the little things I'm trying today. There's another thing that I'm trying, but that has nothing to do with our content. All right, so let me pull up my line paper because that just helps me with organization. And let me check one other thing. We want to go here. It's looking good. You guys said you can hear me. Hopefully the music is not too loud. Let me turn it down some more. This is just for like the people at home. That's like if you're watching this later on YouTube, I just don't want that music to be too loud. Okay, so let's take a look at these questions. So we're in week 4 again. We'll have exam 1 that'll open up this Wednesday. It'll be due this Sunday. You have a lot of support. I also want to bring some other things to your attention. You have a lot of support. So the first line of defense, you got this question help in the upper right hand corner, and the questions will have like view an example. There's an e-textbook say those don't get it, you can do the ask my instructor. Any between those sources, you should be able to figure it out. One, either ask me or view an example. You can also bring up questions during class. We don't have to like go in chronological order. I just do that because students generally don't ask questions, but you should. Like you can ask questions that we can talk about any question during class. Remember, so because I do the lectures in advance, class time is really just supposed to be question and answer. But for me to fill it, I just kind of make my way through the homework. Also, you have tutors and you have your classmates. I know my calculus students, they kind of did like a group me day one. Like they were like, we're gonna do a group me. I was like, that's fine. I encourage that because you guys need to be in communication. You need to work together. You need to be doing that kind of stuff. That's important beyond just my class. Like, it's important. Yeah, so between the tools in Pearson, asking me, linking up with your classmates, and connecting with the tutor, those are like some of your most powerful sources. And honestly, you all working together, you all can explain it a lot better to each other than I can. I can be accurate, but it tends to be information overload and students get kind of like shut down. But I give them like what they need to hear. But you all will kind of work together and you'll say it in a way where it's a lot more receptive. I don't know if that's just like the age gap or whatever. But anyway, so let's take our time and start making our way through these questions. So we're asked to write a linear function that has an indicated value. Let me see, 1.4. Okay, linear, right? Okay, so a library of functions. We have, hopefully you've watched this video, you realize that, hey, maybe I should watch these videos before he starts doing these assignments. So that's why I made them available. I do expect you to watch them in advance. I do try to go into some details during the homework presentations, but all the details are going to be in the pre-recorded lectures. So with the library of functions, the first one, if a linear function, that can be like y equals x or y equals mx plus b, right? That's kind of what we've been doing all the while. So let's kind of take some notes here and take a look at this. So this comes from section, this is a week 4. This comes from section 1.4, a library. I can't spell it, functions. I know you can't see my notes, I'm just taking notes right now. This is question number 1. It comes from section 1.4, number 1. Let me see, find a linear function. Find a linear function, okay, that passes through the points and axis of the sketch graph. We have f of 0 equals 11 and f of negative 11 equals 0. Okay, let's hop over to the tablet. So I think it's like this. Okay, that looks good. I think that's turned up. Okay. So these are the notes that I just took. Basically, we want to find a straight line, the equation of the line that passes through these 2 points, right? So at first glance, when I see something like this, I'm like, okay, well, we have 2 points. Let's write out the ordered pairs. When x is 0, y is 11. So that's the first ordered pair. When x is negative 11, y is 0. That's the second ordered pair, right? I usually like to go just automatically label my ordered pairs x1, y1, x2, y2, right? And then if we want the equation of a line, I usually like to use y equals mx plus b. That's just the one that works for me, right? So we have 2 points. Hopefully you should see that we might need the slope between these 2 points. So let's use the slope formula. The slope, which is the rise over the run, which is the change in y over change in x, that's going to be y2 minus y1 over x2 minus x1, right? This is our slope, okay? So because we labeled our ordered pairs x1, y1, x2, y2, we can just plug them in directly into the slope formula. Now, whenever we're doing our substitutions, my recommendation is before you plug in the numbers, replace all your variables with a blank set of parentheses. All right, wherever you intend to substitute, first replace them with a blank set of parentheses. The blank parentheses help us to keep track of any negatives. Without the blank parentheses, it's very easy to like lose track of the negatives, and it's very easy to make a mistake. Okay, so then now if we plug in, y2 is going to be 0, y1 is going to be 11, x2, oh, wait a minute, let me fix my formula. That should be x2 minus x1. Okay. Let's see, so x2 is negative 11 and x1 is 0, right? So then it looks like we get negative 11 over negative 11. So a number divided by itself is 1, right? So the slope there is 1. The y-intercept is what? When x is 0, so we already have our b as well. B is going to be 11 because that was one of the points that was given to us. So then our equation of our line is going to be y equals the slope, which is 1 times x plus the y-intercept. Okay, hopefully that makes sense. But they want a function, right? This is an equation, so we're going to write it in function notation. It's going to be the same as f of x equals x plus 1, x plus 11, right? So all I did there was I just replaced the y with f of x. They mean the same thing. It's just a different way of writing the same thing. Okay. All right. And then we can check this fairly easily too. Like when x is 0, y is 11. When x is negative 11, y is 0, right? So that's the long and short of that one. So let's hop back over to Pearson. So then we're going to get f of x equals x plus 11. Okay. Let me see my time. Okay. All right. Then the graph, right? So the slope here was 1 and the y-intercept was 11. Notice that the slope is positive. So it can't be a because a has a negative slope. As we trace it left to right, a goes down. So it can't be a. It also can't be c because as we trace it left to right, that one also has a negative slope. It goes down, right? So we can automatically cross off a and c in this case. And then it has to be either b or d. And we said the y-intercept was 11. The y-intercept here is negative 11 and the y-intercept here is positive 11. So it has to be D. Okay. So we just use the process of elimination. Write a linear function that has the value and sketch the graph. Okay, let's do this one. This one's similar to the last. It's not the exact same, but let's see. So question number 2, this comes from section 1.4, question number 5. Let's see, I'm going to say find the function. Find the function f of negative 1 equals 2 and f of 3 equals 10. Okay. Let's hop over here to the tablet. Okay. So we can kind of do the same thing like we did last time. We are given 2 ordered pairs, right? So when x is negative 1, y is 2. When x is 3, y is 10. Okay. So then we can do the same thing. Go ahead and label our points x1, y1, x2, y2. All right. So it's probably a good idea to go ahead and find the slope between the 2 points. So again, the slope is going to be the rise over run, which is changing y over changing x. So that's going to be y2 minus y1 over x2 minus x1. That's going to be our slope. All right. So then before we plug in our numbers, we're going to replace all the components or the variables with the blank set of parentheses for each one. All right. Everything we're going to be substituting. Our y2 is 10, our y1 is 2, our x2 is 3, our x1 is negative 1. See how hopefully it should be clear that like the blank parentheses help us to keep track of the negatives, right? So then if we crunch this number, 10 minus 2 is 8 divided by double negative on bottom. 3 minus negative 1 is the same as 3 plus 1. So that's a 4. This is going to be 2, right? So that's our slope. Now, we weren't given the y-intercept here, so we need to find the y-intercept. I feel like the first order pair is going to be easier. We can use either point to find the y-intercept. I'm just going to use the first one. So again, we're trying to find the equation of the line, so we're going to have y equals mx plus b, right? If I'm going to choose the first point, my y there is 2. My slope we just found was 2. X is going to be negative 1. Only thing we don't know is the y-intercept. If we solve for b, I think we get, that's going to be a negative 2, so b equals 4, right? So we have our slope, and we have our y-intercept. So then the equation of our line is going to be y equals the slope 2x plus 4, right? And then we want it in function notation, so we're just going to say f of x. Let's make that a little bit cleaner. F of x, try again. I'm just being inattentive. F of x equals 2x plus 4, all right? Okay. So again, if anything is not clear, feel free to either unmute yourself or type in the chat. I am monitoring the chat, and when you unmute yourself, I can hear you generally. So okay, and then we can check this result right before we submit it. Like that's the ability to check a question is what made me fall in love with mathematics. I think I may have shared this with you all or not. I'm not really sure, but like when I was taking my English classes coming up, I would do everything the teachers would say. I would read the books, write the report, and then they were always it felt like they were just shafting me. They were just jerking me around. I was like, they'd be like, meh, B minus, C plus. I'm like, why? I did everything you said. I read the book, I write the report. I mean, genuinely. And they had no real good reason. It was just difference of opinion. I got tired of that. In the math classes, even if I had difference of opinions with the professors, if it was right, there was nothing they could do. They had to give me my points, right? And so like checking my work, showing my work, because if I did everything they said, I checked it, and it made sense and it was right. Even if they didn't like me, they had to give me my points. They didn't have a choice. So that's what I liked about mathematics. That's why I just kept doing it because I could, and I was patient. Anyway. So this is everything there. Let's just do a quick check. I'm not going to write out the check right now. I'm just going to check it, right? So for instance, when x is -1, okay, let's see. 2 times -1 is -2 plus 4 is 2. So that the first one checks out, right? When x is 3, 6 plus 4 is 10. So both of these order pairs work. Now we know that this function is linear with this red box right now. We know this is linear because the highest exponent is a 1. So that means our graph is going to be a straight line, it's a diagonal or a flat horizontal line, right? Something of that nature. But we know it's linear because the highest exponent on any variable is 1. Okay. All right, so let's submit this into Blackboard. Like that's about all that we can do there. Yeah, I like it, because now I can jump around. If I have to go to my desktop, I don't have to share. I don't have to stream what's on my desktop. It's only the people that need to see it can see it. Anyway, we got 2x plus 4, right? 2x plus 4. Okay. And then the graph, again, our slope here is positive, so it can't be a because a has a negative slope. It can't be d because that has a negative slope. So it has to be either b or c. The y-intercept was 4. So here, the y-intercept look like it's -4, and here the y-intercept like it's +4. So it just has to be b. Okay, let me see my time. Find the intervals over which the given function is increasing, decreasing, or constant. Okay, so to me, the simplest way to visualize this would just be to graph it. If you have a graphing calculator, you can go to your y equals and graph it. If you don't have a graphing calculator, you can use free graphing software like Algebra.com or Desmos.com for graphing something like this. So then once you look at the graph, increasing, decreasing, and constant means, as we trace the graph left to right, is it going up, is it going down, or is it staying flat, right? So if we were to graph this has a negative slope. So as we trace it left to right, it would be going down. So it would be decreasing over the entire domain. Domain of a function in a graphical sense is going to be the very left to the very right. All right. Domain is going to be the set of input values or your set of x values. I'm going to leave it at that. There are a few other articulations that we can go into, but for right now, that's enough. So the domain is going to be a set of input values. Looking at the graph, it would be the very left to the very right. We say the function is decreasing. The function is never decreasing. The function is decreasing over the entire The domain of this one would be all reals because every x is accounted for. Let's just kind of keep working with those domains, and we'll work several examples until we can see it. My computer is trying to slow down, but it's hanging in there. So we're just going to kind of keep going with it. All right. Identify the intervals over which is constant. It's never constant. So it's just always decreasing from the very left to the very right. Okay. So now the last one we did was an example. The last couple of ones that we did were examples of linear functions. So now this is a cubic function, right? Because the highest exponent on the variable is to the power of 3, right? Is a cube function. So in general, the cubic function has the shape like it's like an S, right? The domain is all reals, you know, for a cubic function, and there's a few other notions. The general cubic function is symmetric about the origin, which means that whenever we have x comma y, we also have negative x comma negative y. So you have all these points that are equidistant, you know, and symmetric about the origin. Like anyway, okay, decreasing. Okay, I think I'm gonna have to draw a picture. The simplest way for this one for me would be just to look at the graph. In general, cubic function is increasing. So as you trace it left to right, it's always going up. But because we multiplied the leading coefficient by negative, it's like multiplying, it flips it top to bottom, right? So instead of always increasing, this one is always decreasing. The function is decreasing. Oh, identify the interval where it's increasing. It's not going to be increasing. And I'm just doing this based on a graph I have in my mind. I'm just not graphing it. I would say pull up a graphing piece of software and graph it and look at the graph. And then as you trace it left to right, is it going up? Is it going down or staying flat? This one should be. Actually, let me look at the graph before I do this. Okay, I'm going to pull up the graph. So let me see the simplest way. I guess I'll pull it up here. We can go like this. Who's this? Okay. I think he was here earlier. Let me close that out. It still looks good. Who's this? This is. Okay. So let me pull up the graph. I'm gonna go here, here. Because at first I was assuming something, but because we multiplied by 2, I was like, wait, let me actually look at the graph. Okay, so let's hop back over to the tablet. We got a negative 2x cubed. It's here, like this. Okay. So let's see, reload and refresh. Okay, this looks okay. So we're gonna go to y equals, I think we said we got a negative 2x to the power of 3. I'm gonna go to standard zoom. I'm just gonna go 10 in all directions. I'm gonna hit number 6. Okay, yeah, so it didn't, I was thinking that it may have like spiked or something, but it looks like so as we trace it left to right, notice the graph is going down the entire time. So yeah, I'm just gonna go with my first line. Yeah, I can close it out for right now. Let's hop back over to Pearson, and again, I just did this based on the graph. There's no interval where the function is increasing, so I'm gonna go with this. Okay. Decreasing over the entire domain. So from the very left to the very right, it's decreasing. Okay, and then it's never constant. Close to the center, it looks like it flattens out, but it doesn't. All right, the table is a complete representation of f decided if it's even, odd, or neither. Okay. So a function being even means that it has y-axis symmetry. The official definition of even, screenshot would be the most simple. Yeah, let me screenshot this. I'm gonna take it from here to here. I would like to share here. So yeah, I remember why I generally stop screenshotting, because it does kind of like slow stuff down. It seems like it takes longer. Let me cancel and try this again. Share, airdrop. So I just got a notification from Apple News. It says the U.S. has surpassed 500,000 deaths. Then they went into something about tragic loss or whatever. Okay. Come on, I need this thing to pop up. Can I copy? This is doing too much. Share. Airdrop. Maybe I have to exit out of this. Let me hit done. Yeah, see, this is why I don't screenshot. Like, it's a much clearer picture, but then it just be moving so slow, and it won't work properly. All right, let's. I'm gonna just have to write it out. So let me take my notes, and then we'll hop over to the tablet. Let me see if it's here. Nope. Man, that's irritating. Okay. Are you doing that thing? You are. Ugh. All right, I'm coming. Just give me a moment, guys. Let's see if I can get this to work. Okay. It's not working. All right, so let me just write it out. All right, so this is question number 5, which is okay. 5. This comes from section 1.4, question 21. I'm going to say even, odd, or neither. Okay. We're given this table x and f of x. We got a negative 100. I'm just writing it out. It's like, and I guess maybe the first time I write this one out, but once you get it, you don't really have to write it out. You can actually just look at it. Minus 1, minus 65, 0, 0, 165, 10, negative 62, negative 62, and 100, negative 67. Okay. Let's hop over to the tablet. Nope. Here. Okay. All right. So even, odd, or neither. So the reason I wanted to write this one out, I wanted to kind of give you this context. So a function being even, let's just use this color. The definition of a function being even, it means that it satisfies the following. Whenever we consider f of negative x, it'll give us back the original. This is the same as y-axis symmetry. Y-axis symmetry. Symmetry. Okay. So a function being even, the official definition is whenever we consider f of negative x, we get back the original. A function being odd means whenever we consider f of negative x, we get negative of the original. That's the definition of a function being odd. A function being odd is the same as origin symmetry. Okay? And then those are the two for even and odd, right? So, another thing that we can say, so whenever we have, for even, whenever we have a point x comma y, we also have, if it's even, that means it's symmetric about the y-axis. So whenever we have x comma y, we also have negative x comma y, all right? So whenever we have the point on the left, we also have the point on the right, okay? For a function being odd, whenever we have x comma y, we also have negative x comma negative y, right? So do we have either the orange case going on or the green case going on, all right? So let's see. So notice we have this xy and then we have the opposite. We have this xy and we have the opposite. No, yep, right? We have this xy and we have the opposite. So do you think that that's even or do you think that that's odd? All right. So this should be an example of the green, the odd one. We have, whenever we have xy, we have the opposite. Okay. So I'm going to say that this is an example of a function being odd. Okay. Let's hop back over here. So this one should be odd. Let's see if we can get another one of those. Okay, so this one I'm not going to write out. Decide if it's even, odd, or neither. Okay, so notice, let me see. We have the xy -1, -18, and we have the opposite. We have this ordered pair and we have the opposite. So this one should be odd as well. This along with the opposite. So I'm going to go, this is another example of an odd function. Okay, let's try another one. Oh, darn. Okay, I kind of wanted to see at least an even one. Let me go back and see if we can get an even one. I'm gonna hit similar question. Okay, so we have, if we do a similar one, we got -1, -68, and that's the opposite. So this is still odd. Let me try the previous one, see if I can get a different one. Save the best score. Let's see if we can get a different one here. And I'm gonna do a similar question. I think these are still behaving. I don't know why they're only giving us odd ones. That's kind of irritating. I couldn't get it to give us an even one, so I'm just gonna go on to number 7. Save the best score. Determine algebraically whether the given function is even, odd, or neither. Okay, yeah, let's write this one out. This is a good one. What's the time? I'm totally not. Okay. So if we get out 50, I'll keep you guys for no more than 10 minutes. Okay. So let's see, number 6. We'll probably do this one and maybe one more after this. This is question number 7, actually. I'm going to say even, odd, or neither. Okay. We're given this g of x equals 7x cubed plus 4. Okay, let's hop over to the tablet, which is here. Okay, so we've seen the official definition for even and odd. We kind of articulate it in a graphical sense. What do we mean by even and odd? Even means y-axis symmetry, odd means origin symmetry. And then, we looked at another explanation. So we can see algebraically how to determine if a function is even, odd, or neither. So this is where the formal definitions come in. For this, what we're going to do, we're going to consider f of -x. If we get back the original, then we say it's even. If we get negative of the original, then we say that it's odd, right? So we're going to consider g of -x, all right? So what we're going to do, we're going to replace each x with -x. Let me highlight that style. Like this. So we're going to replace each x with that blue -x. 7x cubed plus 4. And again, we're going to replace that with the -x. Okay? So -x to the power of 3, if we have a negative multiplied by itself 3 times, is that final result going to be positive or is it going to be negative? All right. If we multiply negative by itself 3 times, the final result is going to be negative. So then that's going to be negative 7x cubed plus 4. Notice this is not the original. And I think even if we factor out a negative, that doesn't give us negative times the original either. So this is an example of something that would be neither. This one is neither even nor odd. So this should be neither. Because we can't get back to the original in some form or fashion. Okay, let's hop to Pearson, check that, and then try another one. Okay. I think we're going to let this one be our last one. Okay, let me write this one down. Anyway, let me not say that just yet. So number 8, I'm going to say even, odd, or neither. Even, odd, or neither. Okay, I'm going to put question mark. We have this f of x equals, we got x to the power of 11 plus x to the power of 9. Okay. Let's hop over to the tablet. So again, we're going to evaluate f of negative x and then see what comes out. So first we're going to replace each x with a blank set of parentheses. And we're going to plug in negative x into the blanks, right? Again, remember, if we have an odd number of negatives, that final result is going to be negative. Negative. And my 11s keep looking like 4s, and I'm trying not to make it look like a 4. Minus x to the 9, right? Same argument. Is this the original? No. But then notice, if we factor out a negative from both of these terms, we're going to get negative times x to the 11 plus x to the 9, which is going to be negative of the original, right? So when f of x equals negative f of x, that's the definition of a function being odd, right? If we had got back the original by itself, then that would be even, but this is the definition of a function being odd. Okay, hopefully that's okay. So I mean, I kind of like went into some of the details of what I was saying during the lecture presentations. I mean, I'm okay with that. Like, if you want to see the details, is there. If you feel like it's a waste of time, you don't have to, but it's there. But you just got to be careful with like not watching the lectures, because then these, the concepts are going to start compounding. And if you're skipping stuff, you can't skip stuff and get math. You want to take your time, slow it down, and go step by step, line by line, for it to make sense. Okay, I don't think I really want to go beyond that, so I want to kind of stop here. I don't see anything in the chat. Let me see. So I'm gonna stop the stream. I know we had at least one student where we were trying to get to the bottom of why wasn't he added back. So I have to. We're gonna get to the bottom. If you don't have any questions though, I'll see you tomorrow about 5:15 to 6:30. Okay. And we're going to end on that note. We're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace. Let me